Hello guys, so in the last class we had discussed about the general classification of organic compounds where I had given you a very brief introduction about different type of organic compounds, and I told you that we will be discussing all of these categories in detail one by one. So the first category what we are going to deal with today is alkanes, and eventually we are going to talk about all different type of chains, what we can have, all different functional groups, what we can have, and what are different prerequisites to know before we start onto the naming of the organic compounds. Okay, so let's start with the alkanes today. So what are alkanes? This is not something which is new. You already know what are alkanes and you have done this in grade 10. So alkanes are the open chain compounds which are saturated in nature. Saturated means which have carbon-carbon single bonds in them. So there are no multiple bonds, only carbon-carbon single bonds, and there are no functional groups present in it. So basically the carbon chain made up of only carbons and hydrogens, no other element present and no multiple bonds present. Such kind of compounds are called as alkanes. These are also called as paraffins. They are called as paraffins because they are very less reactive, and that is the reason why they are called as paraffins. Paraffins are the substances which are inert to most of the things. So they are also called paraffins, and their general formula is CnH2n plus 2. This is something which we are not talking about just today. We have also learned this in grade 10. So you may find my speed a little faster over here. But just in case if you don't know all this, still this will help you in getting the required understanding for all different type of chains what we have. So even if you don't remember what you have done in 10th, still you will be able to understand what we are going to do in grade 11 starting from the scratch, because I am starting from alkane, which generally we don't talk about in grade 11. We directly talk about the compounds having different functional groups and the complex chains naming. So we are doing it from the scratch but on the little faster note. So we have the general formula CnH2n, where N represents the number of carbons, which can start from 1 and can go till any number. Okay, so name of alkane is generally written as word root plus suffix. So that's how the naming of an alkane is always done. Word root represents, when we talk about word root represents the number of carbon, number of carbon atoms in the chain. So word root represents the number of carbon atoms present in the chain. So we basically count all the number of all the carbons which we have, and that helps us in knowing what is the word root. So word root is the name which represents the number of carbons in the chain, and suffix represents what type of bonding exists in your molecule. So basically if you have a carbon chain, you have a carbon chain, and this is how the chain is. So what you can see is you have 5 carbons over here. I have not written hydrogens over here. Let me just write it. So it's CH3, CH2, CH2, CH2 and CH3. Okay, so I have 5 carbon over here. So these 5 carbons are represented by word root, and all the carbons are linked to each other using the single bond. That is type of bonding, and hence this type of bonding is represented by suffix. Okay, suffix what we use for alkanes is ane, and when we talk about word root, it is common for all the compounds, no matter we are talking about alkane, alkene or alkynes. So let's quickly get a brief about the word roots. If N is equal to 1, that means only one carbon is present in the chain, then the word root will be met. If 2 are present, then eth. If 3 are present, then prop. 4 are present, then but. 5 are present, then pent. If 6 are present, then hexa. And similarly, if 7 carbons are present, then hept or sept. 8 carbons are present, then oct. 9 are present, then non. And 10 is present, then dec or deca. Okay. Now, when I said that we have the carbon chain, which have all single bonds, and that kind of carbon chain will be called as alkane, and that ane what we have added apart from the normal word root, that shows the bonding of the bonding present in the carbon chain. So if I have the one carbon chain, one carbon alkane, then the name will be methane. 2 carbon chain and the bonding is all single bond, then it is ethane. 3 carbon chain, then it is propane. 4 carbon chain, then it is butane. 5 carbon chain, then it is pentane. 6 carbon chain, hexane. 7 carbon chain, heptane or septane, anything you can call it. 8 carbon chain, octane. 9 carbon chain, nonane, and 10 carbon chain, decane. Now, If you are wondering how we have got these formulas, you can directly place it in the formula of CnH2n, or you can just use your common sense, place all the carbons with a single bond, fill the valencies with hydrogen, and you will get the same formula. For example, if I take the carbon chain of 7 carbons, so I'll write it as C, 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 and C. So basically, I'll make the backbone of the chain, that is with the carbons first, and then once the carbons are linked through the required bonding, then we will fulfill the valencies of the carbon with hydrogen. So here we have 1, 2, 3, 4, 5, 6, 7 carbons, and now here the first carbon has only one bond formed yet, so 3 valencies unfulfilled. Second carbon has 2 valencies unfulfilled. Third also 2 valencies. Fourth also 2 valencies. Fifth also 2 valencies. Sixth also 2 valencies, and the seventh has 3 valencies unfulfilled. Now if I place hydrogens over here like this, this will make the required chain with all the valencies fulfilled, and the bonding is single bond, which will represent an alkane. If you write it, this is the structural formula. If you want to write it in the condensed format, you can write it as CH3, single bond CH2, single bond CH2, single bond CH2, 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 and CH3. That's how will be molecular formula condensed formula written. And then if you want to write it in terms of bond line, I'll just draw the bond line over here. 1, 2, 3, 4, 5, my bad. 1, 2, 3, 4, 5, 6, and 7. That's how your bond line structure would be. So this is your first carbon, this is second, this is third, this is fourth, this is fifth, this is sixth, and this is seventh. This will be your bond line representation. And if you want to write the molecular formula, count the total number of carbons. So you have 7 carbons. How many hydrogens are there? 3 plus 2, 5, 7, 9, 11, and then 13, and then 16. So H16. That will be your molecular formula, and that's exactly is the formula over here. So 7 carbon chain with all the carbons linked through the single bond, and the name of the alkane will be heptane, because the word root is hept and the suffix is ane, which represents the bonding. Hept represents 7 carbons present in the chain, and ane represents the kind of bonding exists in the carbon chain. So that's how the generic naming of alkanes is done. But this is something which you have already learned in 10th. So right now our motive is not to learn IUPAC naming, but to get an understanding about the terminologies, what we are going to deal with, and some basic information what we need or what we need to understand to get a detailed overview of IUPAC nomenclature. So even before we will start IUPAC nomenclature, that is a standard nomenclature done in all over the world, we will first learn the terminologies, prefixes, suffixes, some common names, and the other terms what we use while naming of a compound. Okay, so this was just a brief what you have learned in there. This is not something which is the part of grade 11th, or this is not something which is new and you are learning. So right now also you will find some topics new and some topics which you've already learned before. But irrespective of that, we are going to just list down what all we need to name the compound. Okay, so even before we start the naming of the compound, we will learn the prerequisites of naming and some common and trivial names. So next, let's talk about, so one by one, now we'll talk about some different groups and the representations what are required to know the name of a compound. The first thing which we are going to talk about is the alkyl groups. What are alkyl groups? Alkyl groups are nothing else but very similar to alkane. Now alkane is a complete chain where the carbon's valencies are fulfilled. Whereas when we talk about the alkyl chain or alkyl group is the part of the compound. That means, let's say, let me just give you an example. If I have, let's say, CH3, CH2, CH2, and then I write A means any other thing can be present apart from carbon, or anything is present which I am not referring to right now. This will be called as some group, let's say. This is some group. What is this group? What we are talking about, what kind of group it can be, we'll deal with later on. This is one part of the compound, and this is the another part of the compound. Now look at this part, the carbon chain part. So if you see over here, I'm going to talk about only CH3, CH2, CH2 and dash, only this part. So if you talk about this part individually, what you can see is this is not alkene. This is a kind of alkene, or you can say this is partly alkene where the bonding is alkane type. That means it has carbon-carbon bond. The number of hydrogens present in same type of carbon chain in alkane will be more than this compound. So see, if I have a three-membered alkane chain, my three-membered alkane chain will be this. Valency is complete, right? So here you have C3H8. But if you look at this part, if you look at this, which was the part of the molecule, it will be C3H7. That means one hydrogen shorter or lesser than your C3H8. So basically, this is not a complete chain. Something must be attached over here to fulfill its valency. If it's hydrogen which is fulfilling its valency with this on this bond, then it becomes an alkane. If it is something else, that means any other group apart from hydrogen, then this part becomes alkyl group, which is also called as substituent group. We can call it a branch, we can call it a substituent group, we can also call it as a residue group. And there are multiple such names. Okay, so this part is one thing, and the other thing is the group which is present along with it. So basically, one valency is getting satisfied by some other group apart from hydrogen, and when that happens, this part of the chain is called as alkyl group, which means when you count the number of carbons and hydrogens over here, number of carbons will be same as an alkane carbon, but number of hydrogens will be one hydrogen less than the actual hydrogen. And there is a general representation of alkyl group also. Alkyl groups are generally represented by R. In fact, R dash. R means any length longer carbon chain. R means any length longer carbon chain. And if you're talking about any molecule, any organic compounds which are not purely alkane but have some other functional group attached to it, or your carbons are not fulfilling their valencies only by hydrogen but something else, then it will be written as Rg. That means R means any carbon chain and then a group is attached to it. So this part of your carbon of your molecule of an organic compound is called as alkyl group, and this R will always have one hydrogen less than alkane then its respective alkane. That means if this R is made up of 4 carbons, the 4 carbons alkane chain will have C4H10 as a molecular formula, but the alkyl group of it will be C4H9 with one valency over here, which will be attached to something else, which will be attached to some sort of group. That group can be made up of carbon, that group can be made up of chlorine, bromine, iodine, but not hydrogen. Okay. So let's come to it. General formula of alkyl group is CnH2n plus 1. What is the definition of alkyl group? When we remove a hydrogen from an alkane and put something else at its place, then it is called as alkyl group. As I mentioned, it's not like the carbon's valency is fulfilled by hydrogen only. The last carbon on whatever carbon, any carbon over here, let's say this is CH3, this is CH and CH2, sorry CH3, and then this is some other group. Anywhere one carbon will have one valency fulfilled by some other group rather than hydrogen. So that is called as alkyl group, and it is formed by losing one hydrogen or replacing hydrogen with something else. And how do we name it? Alkane is the general name. You remove ane out of it and add -il to it. Basically, word root plus -il. That is the name for alkyl groups. Now, such alkyl groups can be branches, can be low priority groups. Low priority groups. What are these? What do we mean by low priority groups? We'll come to it. It can be a substituent group. We can also call it as a residue group. So there are multiple names. Okay. The general formula is CnH2n plus 1. We have removed ane from the suffix and added -il as a suffix, and the name has become alkyl. For example, if you have taken methane and removed a hydrogen out of it, normal methane is CH4, and when you remove a hydrogen out of it, it will become CH3 with one bond free, which is ready to attach to something else or any other group present over there, and the name will be methyl. Similarly, if you have taken propane, you remove one hydrogen out of it and it will become C3H7 with one valency free, and this one valency will go and attach to something else or is attached to any other functional group or anything, then it will be called as propyl. So that's how alkyl groups are named. How to use it, what is the utility of this group name, of this alkyl groups and all that, you will be learning it very soon. Okay, when we will collaborate all the data what we are learning right now and we'll be implementing it in the naming part. Okay, so treat it as small informations what you will be using all together when we'll start naming of the compounds. So now next type of group which we are talking about is alkene. The next type of compounds what we are talking about are alkene. Alkenes are also called as olefins or alkynyls. You have to know these names and these are very important. Alkylenes or olefins, these are the names for alkenes, alternate name for alkenes. Now what are alkenes? Alkenes are the ones which have one pair of double bond at least in the compound. So basically if you have a compound altogether, most of the carbons will be linked through the single bond, but at least one pair of carbon will be linked through a double bond. So basically the compound which have carbon-carbon single bonds as well as carbon-carbon double bonds, such compounds are called as alkene. As again I mentioned earlier also that naming of such hydrocarbons is generally word root plus suffix. The word root will represent the number of carbons and suffix will represent what? The type of bonding exists in the carbon chain. So here the type of bonding what we are referring to is carbon double bond carbon. So all the carbons, maybe you have a chain made up of 4 carbons, but only one pair is linked with a double bond, rest of all are linked with a single bond, we'll still call it alkenes. At least one pair of double bond should be present in a compound to be called as alkene. So this presence of double bond will change the suffix and the suffix will be -ene now. Okay. By the way, if you have 2 double bonds, then this will become diene. If you have 3 triple bonds, then it will become triene, and so on. But we will deal with it later on, so you don't have to worry about it right now. Just ignore this. We will be talking about just ene right now, and when we'll start naming, we will do multiple combinations of 2 double bonds, 3 double bonds, and so on. Right now, let's simplify the things and understand. So, open chain unsaturated hydrocarbons having carbon double bond carbon are called as alkene, which are also called as olefins or alkylenes. General formula is CnH2n. Again, n is the number of carbons which will start from 1 and can go to any number. Suffix is ene or ylene. Ene is the most common one what we use, but ylene is the one which you may get in your competitive exams, and at that time you need to know, or that time you should be able to identify what compound they are talking about. So it's not necessary for you to use this suffix, but in competition exams when they are giving you a question with such suffix, you should know that they are talking about the normal alkene, nothing else. So there is nothing complicated in the compound, it's just a simple alkene. Let's see some examples of alkenes. You have CH2 double bond, CH2 basically 2 carbons, so the word root will be eth, and because it's a double bonded molecule, so name will be ethene. And instead of ethene, we can also call it as ethylene, as I mentioned, that suffix is ylene. Similarly, we have the chain over here which has 4 carbons, so 4 carbons, word root is bute, and then ene as a suffix or bute, and then ylene as the suffix. Though the naming is not as simple, these are just some examples so that you get aware of the names, you get aware of some terms, and when we use it for the different compounds, the ones which are a little lengthier, which have further things attached to them, are not as simple as these ones. You should be able to implement all this what you are learning. So this is a small chunk of information you are getting in the bits and pieces, and then you have to collaborate all of these and then use it when we'll be doing the naming part of it. Similarly, you have propene with 3 carbons, so 3 carbons word root is prop. You can use ylene or you can use ene, anything you can use, and that will give you the name of alkene.
So next we'll talk about another group, that is alkenyl group. Now alkenyl group is similar to alkyl group. If you remember, what we had done in alkyl group is that from the alkane chain, from one carbon, if you remove one hydrogen, and at the place of that hydrogen some other group is attached, then that chain is called as alkyl group. Similarly, from an alkene, in alkene, whatever the carbons are there, from those carbons, if I remove one hydrogen and then substitute it with some other group, or some other group fulfills the valency of that carbon, then that is called as alkenyl group. For example, just see, if I have taken let's say CH2 double bond CH2. Now instead of CH2 CH2, if I write it as CH2 double bond CH, now one hydrogen is less, and now this is not, the second valency is not fulfilled, I mean sorry, the fourth valency is not fulfilled by hydrogen but some other group, let's say G, then this group or this chain will be called as alkenyl group. Okay, or let's say if I write it as CH3 CH double bond CH2, this is my chain, and I choose to remove a hydrogen from here, and I write it as I'll just write it over here, I'll write it as CH2 group over here, CH double bond CH2, then also this will be called as alkenyl group. So it doesn't matter from where you have removed the hydrogen and which part of your alkene chain is attached to some other group, but it should have one hydrogen lesser than your normal alkene chain. I could have removed the hydrogen from here also. I could have made it like CH3 C group double bond CH2, then also this will be called as alkenyl group. Okay, so basically from alkene, when you remove a hydrogen from any of the carbon, the group will be called as alkenyl group, and that carbon's valency will be fulfilled by some other group instead of hydrogen. That's all. So look at the example over here. I have taken CH2 double bond CH2. I have removed hydrogen from here, so it is CH2 double bond CH, CH2 double bond CH single bond. This will be the part as I have shown it over here, and this part has a specific name, and that is a common name what we use over here, and that is vinyl group. It is very very important name. This is called as vinyl group. So CH2 double bond CH single bond, this part is called as vinyl. Similarly, I have taken this compound and I have removed the hydrogen from third carbon. Okay, so this third carbon will become CH2 double bond CH CH2. This also I had just shown you in the example. This group also has a specific name. Now here we can have multiple different type of structures, but I have just chosen the few which you will be learning going forward also, which have some common names and very widely used names. So when the hydrogen has been removed from the carbon, when the hydrogen has been removed from the carbon, neighbor of the carbon carrying double bond. So second carbon had a double bond and I have not removed the hydrogen from second carbon. Neither I have removed the hydrogen from the first carbon which was carrying double bond. Instead, I have removed the hydrogen from the third carbon, which is the neighbor of the carbon carrying pi bond. So third carbon is the neighbor of carbon 2, which is doubly bonded with carbon 1. Okay, so such kind of structure is also, as I told you, is an alkenyl, which is a generic name. The specific name to this group is allyl group. Very important. Again, it is very important. You need to understand what's the difference here. Removal is from third carbon, and that third carbon has this single bond with the second carbon. Second carbon is the one which is carrying double bond. So it is neighbor of the carbon carrying double bond. It itself is not carrying any double bond right now. Okay, now if I have removed the hydrogen from the carbon carrying hydrogen, okay, let's see the second part of it, from where the hydrogen has been removed. Now if the hydrogen has been removed from second carbon over here, which is the inner carbon, not the outer carbon, so there are two carbons in the chain. One is the outermost carbon carrying a double bond, and another is the inner carbon carrying double bond. So I'm talking about the inner carbon right now, which is second carbon. If I remove hydrogen from the second carbon, Basically not the terminal one, non-terminal one, this one. Then what will happen? This will become CH2 double bond C single bond CH3. That's how it will look like. So that's how exactly it is looking like. Just the shape has been changed a bit, but that's how it looks like. And this kind of compound is called as isopropenyl group. Iso due to the branching of the CH3. Now when you will form a compound of this, let me just show you a compound also of it so that it becomes much clear. So it will become like this. So that's how it will be. There will be a group present over here. Okay. So what you can see here is there is a group here. There is CH2 double bond C and single bond group, and then CH3. So CH3 is acting as a branch over here. So it's a branching. So when you have one CH3 branching like this, we use a common term. It's a common term. It's a trivial term. It's not the IUPAC naming. It's a common way being used by multiple different you can say chemists and all that. So iso means the branching of one CH3. We will be learning this iso and neo in much more detail. But this kind of bonding where CH3 is acting as a branch is generally called as iso. Okay, isopropenyl. Why it has been called isopropenyl? Propenyl because it is made up of three carbons, 1, 2, and 3. Enyl because it is alkenyl group, so its suffix will be enyl. Understand this. Prop due to presence of three carbons, enyl due to the structure of an alkenyl group, not an alkene group, or not an it's not an alkene, it's an alkenyl group. And why I have used iso? I have used iso to represent that there is a CH3 of this propenyl which is acting as a branch. It is acting as a branch. Let me just tell you one more thing. So if it would have been like this, let me write it over here. So if it is CH double bond CH single bond CH3, and there is a group over here, this is one thing, CH2 CH CH3, and the group over here, this is another case, and the third case is CH2 double bond CH single bond CH2, and then there is a group over here. So these are three different type of chains what can be formed using this. Now you have to understand one thing. This kind of structure where the carbon chain is made up of three carbons only, and then there is a group attached over here. That's the reason why I have written the CH3 is acting as a branch, acting like a branch over here. Just let me make it a little clear. So this is the thing out of which actual chain actually this is the straight chain, and this is acting as a branch over here. And because of the presence of the CH3 branch, this is called as isopropenyl to represent that the alkenyl is made up of three carbons, out of which one CH3 is acting as a branch. Okay, and then this will be called as what? This will be known as allyl group. I've told you already, where G is present on the carbon which is neighbor of the double bond, this. So third case is CH group double bond CH single bond CH3. Now this this compound can be called as propenyl group. Now there is a difference between this and this. That is the reason why iso term has been used. Ideally, we will not use propenyl name over here. We will use some other common name, but let's not talk about it right now because it will lead to the confusion. So what I'm trying to tell you is iso term has been used to just represent that out of those three carbon chain which was making an enyl group or alkenyl group, one carbon is acting as a branch, that is CH3, and rest is attached in the normal straight chain. Second carbon is carrying a group. To just give you the difference between first, second, and third type of chains, the iso term has been used. Usage of iso we'll be learning furthermore, so don't get confused. Don't feel like, okay, I have not understood this, so this is the end. We are going to understand iso going forward in detail. Similar example, we have shown it over here. So this is my butene, and I have removed a hydrogen from here. Hydrogen has been removed from here, and this is the compound looks like. And now this will be called as butenyl group. So that's how it will be named. It will be named as butenyl, propenyl, ethenyl, pentenyl, and so on. Now there are some other complications are also involved in it. What all those complications are, we will talk about it when we'll talk about the IUPAC naming. The next category we'll talk about is alkynes. Alkynes, again, we know already, we have learned this in grade 10th. Those are nothing else but the chains carrying carbon triple bond carbon along with the carbon single bond carbon. These are also called as acetylenes, and acetylene, it is called acetylene because it's first compound. That means whatever alkenes we have, the smallest alkyne is called as acetylene, and that is the reason why even the whole group is called as acetylene. Same way as in the periodic table, oxygen group means the group carrying oxygen at the top, or the carbon family means the family which has the first element as carbon. Exactly same way, acetylene family it is, and why it is called as acetylene family, because acetylene is the first compound or the smallest compound of alkyne. So here, we in the common system, we also call it as acetylene because the first member of this family is acetylene. What is the first member of the family? CH triple bond CH is the first member of the family. General formula for alkynes is CnH2n minus 2, where N is again starts from 2, goes to any number. One does not exist in case of alkenes and alkynes. The reason behind that, you require at least 2 carbons to show that multiple bonding. So even in alkenes, N starts from 2, and even in alkynes, N starts from 2. By mistake, I think I have spoken about N in case of alkenes is also N is equal to 1 till any number. It's actually N is equal to 2. Why it is N is equal to 2? Why the list start from N is equal to 2? Because when you have to represent the multiple bonding, you require at least the pair of carbons to show that. So basically, carbon double bond carbon or carbon triple bond carbon will require at least 2 carbons to show this alkene or alkyne nature. Hence, the list always starts from 2 carbons, not from the 1 carbon, unlike alkanes. Now, the common names are acetylene and its alkyl derivatives. Acetylene, as I mentioned, is the first member of the family, and the common names we give to such compounds using the name acetylene as a base. It is like the eldest member of the family is the primary name, and then other names are the secondary names we have been putting later on. So that's how it is. Let's understand what do you mean by derivative. Derivative means the ones which have been derived from this compound. That means the ones which have the acetylene part plus additional part. That means if you have a 3 carbon chain carrying a triple bond, it's like this. If you have C triple bond C single bond C, at least this part will be still called as acetylene, and any extra carbon will be named as alkyl group, as an alkyl group. Let me show you once more. CH triple bond C single bond CH3. So this will be called as acetylene. And this, I told you, CH3 is not an alkane. CH3 is an alkyl. And alkyl made up of single carbon, that means word root is meth. And because it is alkyl, it has the suffix il, so it will be methyl. So it will be methyl acetylene. That will be the name of the compound, methyl acetylene. This is a common name, by the way. This is not an IUPAC name. This is not under the rules of naming. So we basically do not consider the CH triple bond C as the part of the chain. We do not name it all together. We name it separately as acetylene, and rest of the carbons are named according to the alkyl group names. That's how we name in the common naming. But when it comes to name using the proper rules which have been designed to give the scientific name to these compounds, we follow the normal procedure, that is word root, which tells the total number of carbons plus suffix. So basically, if I take the same example, that is CH triple bond C single bond CH3, total number of carbons are 3, so we will call it prop. And the suffix what we use for alkynes is ion. Ion, Y-N-E is the suffix for alkynes. So we will write it propyne. So normal IUPAC name, or you can say the standard name, is propyne. Common name is methyl acetylene, and so on. So on for the other compounds. So we will see the examples now. So here I have shown you methyl acetylene, how we have given the name methyl acetylene, which has the IUPAC name as propyne, and CH triple bond CH, I told you, is the first member of the group, and hence it is called as acetylene, and its IUPAC name, or IUPAC name is nothing else but the scientific name. We will learn and understand what exactly the IUPAC name means and what is the full form of IUPAC. But for now, you can understand that this is the standard scientific name being used worldwide in the same manner. Okay, so the common name is acetylene and the IUPAC name is ethine. Eth for your two carbons and ine is to represent the bonding structure. Next is alkenyl group. Again, this is the third time we are repeating the similar thing. So basically, alkenyl group is nothing else but from an alkyne, if you remove a hydrogen, then it will be called as alkenyl. We have CH triple bond CH. I have removed a hydrogen from here. It has become CH triple bond C, single bond over here. So it will be called as, it will be named as word root plus enyl. That's how it will be named. So you can say for alkenyl groups, the suffix is YNYL. YN to represent, basically when you talk about alkynes, the suffix what you use is "ine". So what we have done is we have just removed the E and have put YL over here. So I have just mentioned it over here, minus E and plus IL. This is the suffix for alkenyl group which has been produced by removing one hydrogen from alkynes. Similarly, I have CH3 single bond C triple bond CH. I have removed a hydrogen from here and it has become, you can remove it from here or you can remove it from here. Either way you can remove. So it has become CH3 single bond C triple bond C single bond this. This will be called as propionyl, prop because of the three carbons, and ionyl to represent that it has a triple bond and it is an alkenyl group. Alkynyl group. Okay, so that's how we name them. Mind it, we do not use common names very often. We do not use common names for the generic use. We use the standard names only, but you may get the questions having common names and you should be able to identify them. This is the reason why we try to understand the normal standard names as well as the common names. Okay, let's go to the next part of it.